Thank you, Anton and Livia, for the initiative. So, for all that don't know, RSPI is the Romanian Society of Bioinformatics. I can also put the link in the chat about us, but it's mostly in Romanian. So, but there are also pages which are in English, which is good. We are moving towards English slowly but surely. We are a society that was built a couple of years back. Also here, co-founders like Robbie, they had an aim in mind to kind of bring together all bioinformaticians from Romania, which at that time were a little, and we want to grow the community and offer them more training and more exposure to bioinformatics and research in general. So if you are like maybe a student studying at a master's in Romania, and you already want to be more in touch with research in general, please join us. We are always happy to have new courses, and we have also different events. So in maybe it's interesting for you, in October we will have the next round of conference, or Raw Bioinfo, which is the bioinformatics conference, which it's like now third edition, where it's a very regular bioinformatics conference, but held in Romania, in Bucharest. If you are interested, we will put soon online more details. And yeah, that's in a nutshell the society. And now I would like to shortly introduce Anton and Livia. So today we are here for the Bioinformatics AI workshop about LLM agents and bio-MCP, what we will learn about today. So Anton is a bioinformatician working in Rostock, but he works with bioinformatics since 2015, if I understand correctly, working on multiomics projects, doing a lot of NGS pipeline processing, applying them on large cohorts, and also using machine learning to extract patterns from gene expression, and now newly more using also LLMs. He co-founded just-dna-seq. Maybe he wants to say some words about this. And he also co-founded Longevity Genie platform. That's also something that Livia works on. So Longevity Genie, it's a chatbot, if I understood correctly, but I'm very happy if you also introduce your products. But Livia also, I would like to say that she is actually an architect by education, but now she's working and has actually her own startup on Glucose DAO, which is an interesting tool to monitor glucose in patients. And I think that's a very cool thing to work on. Yeah. What did I miss now? I think that's in short about Anton and Livia, and I let them talk now. Yeah. And yeah, I'm just in the society. I'm Modelina, and I'm also doing bioinformatics because I forgot to introduce myself. But yeah, okay. The stage is yours.
So thank you very much. I am also in Robi Takutu group, so I am like part-time in systems biology of aging group here in Bucharest, and also in the Institute for Biostatistics and Informatics in Medicine and Aging Research in Rostock. And I am also very grateful for Robbie here. Also, he is also the person who helped us with Cell-Fabric account for this call. And let me tell a little bit of what I'm doing. Yes, as it has been mentioned, I am also co-founded projects like just-dna-seq and Longevity Genie. And for just-dna-seq, I think while I'm talking, Livia and Newton Winter can give links. So this is a platform to actually analyze your own genome. And the motivation for this was that I didn't want to be like people say shoemaker without shoes, so like bioinformaticians that cannot analyze their own data. And we created this project. We started it originally with Newton Winter, and with time it got some decentralized science funding, and it grew. And any of you can actually use it to analyze your own genome, or if you haven't for some reason sequenced yourself, you can analyze other genomes. So I'm just quickly opening some examples. So for example, is a report like my genomic report. It looks like we have different genetic variations. So each result has like red is bad, and there are details like what has been found, and also some LLM generated recommendations. So we have a lot of stuff, mostly focused on longevity, and also we have ways to actually put some filters and play a bit with like analysis of specific polymorphism. Like for example, now I am putting pathogenic, there should be pathogenic somewhere, SNPs, and we'll see it probably on my genome. Yeah, so this is while it's loading. So this is one project, and it happens that we were at Zuzalu pop-up city 2 years ago with Newton Winter, and there was it was a time when ChatGPT 3.5 and then 4 emerged, and there was a hackathon there, and obviously we tried to apply some stuff for longevity. So here how Longevity Genie was created. So it's actually a stack of libraries. So now I'm showing the chatbot that you can ask very specific questions that LLMs often don't know, because they are good in popular topics, but some cutting edge research or some very technical details, especially details from databases, like, some specific RSID, it may not know it. And this is examples that we built some LLM agents. So we started because we had genomic expertise. We started with AI agents for genomics. And while we were talking, actually, we now have pathogenic filters of pathogenic variations in my genome. So you can like see that I have in APOA too. So I have some not nice stuff, and like everything. So actually, all of this is also in the reports. It's more like you can manually investigate. So there are different annotations and properties, and some of them you can actually click, like you can click what it means, and this you can read. And Longevity Genie, it's the first thing that we did is that it answered genetical questions. And as a side effect of this development, so we have so for both just-dna-seq and Longevity Genie, we have GitHub organizations. And for just-dna-seq also, because Romanian genomics project has started, we expect to build some new features. But today I will mostly be sharing what we developed in Longevity Genie. So in the GitHub organization, you can, as you can see, we have multiple repositories. And originally, so what really amazes me still is that in AI, because everything is super fast, you can have libraries with tens of thousands of users that are extremely buggy and terrible to use. And we started using LangChain, one of the most popular library, but it was so terrible that we actually had to write down just agents library. With this library will be used in today's workshop for actually showing examples. But overall, the trend now is that most of agentic libraries, like those that are good. I'm not talking about LangChain, but I'm talking about things like Hugging Face Small, like Autogen, like Pydantic agents. They are very similar. So by understanding what we do, you will have ideas how normal libraries actually work. And in the beginning, we just answered questions with literature and like databases. But now, because everything like develops very quickly, we actually started also adding things like model concept, context protocol servers, and some other advanced stuff. That focus on bioinformatics, because for aging, you actually need to know most of the biology. Yeah, so today, like, we will start the workshop. We will, so Livia will explain the most like basic things with LLM agents. And before the workshop, we also made an email with some relevant links. So we start basic, then we go to examples that also involve bioinformatics, and in the end, I will show like the one of the newest trend called model context protocol servers that can integrate in already like existing AI tools like Claude Desktop or Cursor or any other tools, and actually that you can use as bioinformatician regularly in your coding environment and also in like advanced chats. And now I will probably switch word to Livia, and Livia will show you how to actually start working with agents and what are the basic actually principles of the work. Livia?
Yes. So first of all, I'm going to share the link where you could find the collab. Let me get a bit and put it in the chat. So here is basically where the notebooks are. I'm going to also share screen to have things. Okay. So I have the same link I've shared you. And here in this page, basically it's part of the library Anton has been telling you. We've developed it especially for people who just want to try and do not have IDs installed and so forth. So they can experiment them in Colab. You have this wonderful little button, open in Colab. You just click it. And if you have a Google account, it should open the Colab part, basically. For those of you that haven't yet worked with Colab, because I'm not sure if everyone does, it's an environment that allows you basically to run scripts online. You don't have to install stuff on your computer. It's more like a click and play stuff. So we can see how the code works. That's why it's very useful for training. And here in the first notebook, we basically approach the starts and the basics. So first of all, in my case, I might have this green tick here because I already tested the notebook and I haven't restarted. So I have a previous instance. But for most of you, it wouldn't be. So you just have to press this play button. You'll get this wonderful notice from Google that it hasn't been created by Google. And you say execute anyway. And here, basically, it's installing the library. What you would have done on computer when you would say literally pip install and you would download the library from the repo Anton has. It should be pretty fast, I think. Yeah, because in my case, it's requirement already satisfied. And here, after you install the libraries, we'll get to the keys. Anton, be on on cue with the keys. The keys are basically the API keys used to process here. We updated now to have Gemini and Perplexity. You could have any other model. You could have OpenAI, you could have anything you've paid or created a key for. Anton, you have some keys prepared for the workshop, right? That you'll share.
Well, yeah, we shared some keys, but it's actually still recommended to, even if you already have keys, because we gave links where to make it with Google or with Grok. I mean, I give just in case links where you
Gemini, for Gemini and Perplexity we need, because I updated. Well, Grok.
yeah, I will copy like the keys for those who haven't done it, but
Okay.
the key limitation for keys is that even commercial keys, they have like a rate limit, and we have many people now. So if you can quickly make a key with Grok and with Gemini, better do it, because otherwise some of you can have problems that too many are
Requests.
requesting, and it overloads.
Okay. So basically for Gemini, can you provide the link? Because I had it.
I gave a
Okay.
link, and
Okay.
I will just a second. I'm checking the document with the keys. It's actually same keys as you got with the email.
Okay.
Today.
So while Anton is sending the keys, you basically just have to, well, in my case, like I said, it's fast because I ran it. But you just click play. At a certain point, you'll get here a message, please insert your, in this case, Gemini API key. And you'll just have to copy paste and then enter the key that is the Gemini key which you have, or that Anton shared. And after that, they're going to ask you the same thing about Perplexity. What is good here, you can see basically the code. If you need to switch anything, so for example, if you would need Grok key, we might get to that later. You would just have to add literally here, like Grok API key OS environment get Grok API key, and then copy this paragraph. If not, Grok API key, this thing. What's nice about it is that during this run, I mean, while we are in this notebook and in this session, you will maintain the key. So you don't have to input it every time the key is required. That's why, for example, for me, it ran like in 0 seconds because I ran trials before. But in your case, it will just take time to copy and paste. Maybe I should wait a few moments for people to input. And explain a bit about the models while we're here. Why I said it varies in between Grok and Gemini and Perplexity. Well, they're kind of different models, and why I don't bring up OpenAI. OpenAI is kind of the most stringent, let's say, for the free tier. And you have stuff, but you don't have enough, let's say, context if you go free. Also, in case of Grok and Gemini, for example, we've received notice like 10 minutes before the workshop that Grok is kind of unstable today and we should switch to Gemini. That's why I was furiously editing, and you'll find notation about Grok in our notebooks. The thing is, they're kind of equal in, let's say, intelligence or in answering. They're a bit less intelligent than OpenAI, but they have larger context size. That's one of their things for the free tier. Yes, Anton?
Well, actually, they are more intelligent than OpenAI. In case of Gemini 2.5 Pro, it's in majority of cases is better than ChatGPT 4.5 or 4.0. But obviously in different use cases, different models like Excel. In case of Llama 3, Llama 4, they are indeed, as Livia said, less intelligent, but it's like one of the most popular open source model by Facebook. And for different, so typically, for example, how I do it, I switch between different models when I write code or other stuff. And for coding, usually Claude and Gemini 2.5 are good, but for other purposes like nice emotionally looking text, I think ChatGPT 4.5 used to, but I think it's already deprecated, was good. And reasoning models are good for like strong problems, but at the same time, reasoning models are extremely stubborn, and if they make a mistake, it's very hard to make them change their mind. So this was a
get
bit
to the
off
stubbornness.
topic,
Yeah.
but let's come back.
Okay.
Livia.
So I assume that you managed to insert the API keys. If you're like behind, just raise a hand or something. I'll just go for this next part of script. You just run it. It's a pretty short comment. It's because you have a large context and you don't want to have like it cut. You want to have the whole dialogue, and that's what it is for. And here, basically, we start with the most things, simple things. It's the calling a function. Here, we just do a simple function. It's just defining it. So it doesn't really run somewhere. It just defines a function, get current weather. And here, it's just provided the information. It doesn't do any search. It just shows how it gets it. In the following code block, we have the agent, which, as you can see, is defined with LLM option Gemini 2.flash. So if we run it, it says that the agent basically is initialized. So here you just created your first options for the agents. And now it's a bit of explaining about the models in this section. You can actually switch, like I said previously, within any models as long as you have the API keys. And they are found in this wonderful file, LLM-options.py, to which you have actually a link here. It's in the text. And you can check there what models are up to date, or you can actually update your own. I mean, it's not impossible. And here, we actually use the agent. So we give a prompt. What's the weather like in San Francisco, Tokyo, and Paris? Because we know that's the data we've inputted. And we want to see the reply. So actually, here what it does, it gathers the data we've already had, and it serves it in a human understandable or formatted way. That's what LLM does. They like take text and serve text in different formats. Because at a certain point, we all forget that's how they work. It's not some kind of weird magic behind them. And here, we show how they work with a nice output. So this is basically what it output. The current weather is whatever. And this is like what happens. System, you're defined. You're a helpful AI assistant. The question, the prompt is the green one, what we've asked. And what the assistant does, it says, oh, I don't know, but I have this wonderful tool, get current weather. And it calls to current weather. I have to search with this keyword. And from get current weather, he gets the reply. And he continues to call it several times. What I want to show you, actually, it's because this agent has been initialized in this notebook. If we scroll down, see, I already have it twice. You might wonder why, because I already called it only once. This happens because basically in this weather agent query, I did call it twice. See, I called it here, weather agent query prompt, and I already called it here. So it has memories of all its previous messages, basically. I thought it was an error until I noticed, and it might actually be of importance in case you have to store or you have large informations. And we'll see a bit later what happens there. Yes, Anton?
I also wanted to add for like people that in fact there is like no magic behind what LLM does. It gets like a text, initial text that it has to extend. The format here, if you, Olivia, if you scroll a bit on top, is that you actually, what is visualized here is that you give a JSON array of messages, and each message can have a role and a content. So technically, you run a completion function and ask it to extend this JSON array with another element. And if it is system, it's a system prompt that you give like instruction how to behave in the beginning. Obviously, user is what user generates. Assistant is what assistant replies. The tricky question is actually tools, because large language models, they cannot call anything. In fact, they can only generate the text. And the way how people solve the problem of calling is that in most of agentic libraries, including ours, you have a code that parses the completion text, or actually it's JSON, completion JSON of LLM. And if it sees a role tool, it checks which tools are registered. And in the beginning, when we created the base agent, we registered the tool. And in the tool, what you notice, the first command is extremely important, because LLM, it learns, so it actually gets those tool arguments, and also we parse first comment of the tool. So based on this comment and on the syntax, it figure out if the tool is useful or not. And LLM, it only generates a message called like a tool call. And then the agentic library, it actually does, it parses it, and it does the actual code calling. So LLM doesn't call any code. And then it calls LLM again, and it extends, so it gives previous messages. It gives a tool call result. So you see a tool and you see response. And then after LLM got a response, it just continues the text completion. It can decide whether it wants to just generate text, or it needs to call another tool, or the same tool with parameters, as you can see in those messages. Also, important thing is that in some cases, for example, Gemini Pro, what they did, they actually added some tools that are called on Google servers, so like Perplexity and Gemini 2.5 Pro with search. They actually, in their answers, sometimes they can call search results, but it's kind of the same logic. The only difference is that those search tool is called not in our machine, but at Google server.
Okay.
Yeah.
So this next example actually shows you that it's not like made up stuff by the AI, because also they have this thing. We have the get weather by city function, where we actually say what it does. So it's a weather prediction by winter lover. We wrote that to be like specific, it's here. And we wrote like a message. It doesn't matter. So whatever they ask, because this is the only tool it has, the response is, the weather in Rostock is snowy and there are numerous frozen lakes, like said here. If we would have called it like, I don't know, what's the weather like in Jamaica, it would still be snowy with numerous frozen lakes, because it has get weather by city, which is defined here. And it says this is a weather prediction, prediction by a winter lover. So basically, it shows you that it used that tool. This is for what this small coast is. And because we already talked about the weather, we said, okay, let's do the proper implementation. And here, this long stuff, it's basically the actual weather of a city. You just have to play it here. And then you can fill in this get weather by city. I put Berlin, for example, but for example's sake, and since most are in Bucharest, let's see. Let's add Bucharest. Let's see what it says. So it's 25.9, seems plausible, with a wind speed of 6.6 kilometers. So it gets the data you've wanted. And basically, the function works. Let's see it work with an agent. I mean, I want it to be nice, like a weather report. And here, it's the trick of the Gemini. See, I told you some models are more, well, let's not say stupid, but less intelligent than others. In this case, it's Gemini 2 Flash. And Brazil is also a city, not only country. And it can't differentiate between this and say, I can't get the weather for entire country. However, if we change it to, I have no idea, Sao Paulo, something, Rio de Janeiro. I want something tropical. Doesn't matter. It should know because it's a city. So look, they have wonderful 29 degrees with little wind. So it doesn't know to make autocorrection. I had an issue with misspelling. Usually, like when you type and search for Google, for example, you have autocorrect. We couldn't find your text. Maybe you wanted to say that thing. In this case, Gemini 2.5 Flash is not that smart to autocorrect the example that was with Brazil, and says, I don't know what you're talking about. I don't know country weather. I can tell you city weather. That's and if we go to pretty print all messages, we can see it here how it works. So system was the default basically prompt. Then the user what we asked. Assistant, okay, let's call it, and tool return the data. Then the assistants made it very nice, like a weather prediction, like they should do it after your late night news. So that's how it works. Now we're getting into the, let's say, more fun part, the chat agent. Until now, we had basic agents, and we learned how to use a tool with an agent. So basically how an agent can automate like running a code. Here, though, we have this wonderful picture of a character we might not like. We wanted to show how you can simulate a character. So let's run this code. We're creating a chat agent, the chat agent of Donald Trump. And in chat agents, you have like role, goal, task. And you want to have it speak like Trump. So let's see what happens. So here it is. Well, I think actually its tone, it's pretty similar to the one Trump uses. So it's actually pretty accurate. But to actually capture a character is a bit more difficult. In this example, we had a known character. I mean, you have data on the president of the United States or even former presidents of the United States, like most likely in the training of the model. But that doesn't happen all the time. So we'll tackle this particular issue a bit later. For the next parts, I'll actually show them here because I disabled the Grok Gemini part, and I'll explain. What we've talked is like, we can have agents, they can automate your script, that's all great. Can we automate our agents? Like, I want to have a list of agents that do stuff. I don't know exactly what stuff, doesn't matter. It's important you can do it. So in this part, we basically download the YAML where we have a list of agents, or a series of agents defined. Again, in my case, it was pre-downloaded, but it won't take that long in your case either. Here, actually, these two code blocks you can run because they don't have keys. They don't require keys. It's import YAML, and we want to see what's inside the file. So let's look a bit inside the file. As you can see, it's agent profiles. You define the type of agent. This is chain of thought agent, a model of agent that was developed a bit earlier. The LLM options, basically what model it runs. And here is where I told you we'll have issues because I took out the grok keys due to it being unstable today. Temperature, which in case of model, I was going to say agent, but in case of a model, it tells how much it's going to hallucinate or not. So in temperature 0, it should give like the first idea that comes to its mind. Like Anton said, it's auto-filling. The first thing that fits best, that's what's going to go with. And tool choice auto. And it has apparently a series of tools called letter count in this case. And it's defined here. And the simple weather agent defined again with a grok and without tool. So this is a YAML. You can write your own YAMLs and define your own agents. For example, maybe you don't want to input in code every time to create an agent that does stuff, because it's the same thing. You just want to add another tool. So I can survive having a YAML that I occasionally add. So here is how it would work. Probably you will receive errors due to lack of API key at a certain point. The first part is installing the examples because it has the tools, basically, the tool files that are required, which are defined in .py files normally. By the way, this workflow also shows you how you can work, let's say, outside of your office, because often we kind of wonder if we need like supercomputers or if they're all dependency installed, and if I go somewhere, my wonderful workflow will not work. You can have things stored on Git and then download it in notebooks and to run it. As long as you don't use complicated stuff, complicated for notebook stuff like Docker containers, which is a headache with notebooks. We haven't yet figured it out. You can actually run your pipelines online. So you can have stored your files somewhere on Git, and then you can run it on your, I don't know, computer from home, friend's computer if your computer crashes, as long as you have access to your Google account. Let's see. So here is how it would run if you'd have the API key. The chain of thought agent, you are an expert AI that explains your reasoning step by step. And here is literally what you give for it to explain. You describe the steps of reasoning and the things we tried with. At a certain point, it was with strawberry issue. And here it was a matter of tokenization. It was count the number of letters in the word. It doesn't matter the word. What it matters is that we as humans see the word as an entity, which is probably broken into syllables, and we can identify stuff. The AI does not see it as that. It sees it as tokens. And tokens might be a word or might be part of a word, causing it to miss sometimes some letters. So that's why this letter counting test was so famous. Well, it still is famous, I think, but they did train it to get around it. So in this case, just wanted to see if they have what the numbers of letters they had. To verify, yeah, So basically here it's cycling. That's why I told you just this part, it won't work. Well, we can actually edit it, but I don't think it's important, and to get the draw key. And here it's actually a more fun example. Calling a vision model. We have this wonderful picture of what everyone would recognize as a cat. And we want to know if like our model can tell us what's in the image. Actually, I think you have it also in Google, something similar, like you put a picture and you say, what's this? And let's see. The animal in the image is a cat. Okay, it doesn't give us like lots of description, but then again, we have to keep in mind we're not using like the latest model or the smartest one. We just want simple description. I mean, it doesn't give me reference. It doesn't tell me it's a slightly tabby orange. Okay, it's not orange, but light brown and striped cat. But it tells me the main thing. Yes, Anton?
Maybe just out of interest, can you ask, change the prompt and ask it to explain, to describe it in details? Just curious.
Okay, let's.
And also, I recommend when you like see those examples, you try to modify the prompts and actually see how things change.
Let's see. Let's see. Describe the image.
In details, maybe.
And it's thinking. Let's see what the result is. Wow. A medium shot of a tabby cat sitting upright on a texture light colored wall. So as you can see, prompt is important actually. You can save more from the prompt than from the model. There are two actually approaches. Approaches that you expect the model to know a lot of stuff and you just say solve it or do it and it does. Or in this case, you prompt it specifically, describe the image in details, and it's going to tell you. Look, it even tells me the lightning, possibly sunlight. I'm surprised it didn't tell me it's a winter month. Anyway, yeah. So as you see, it can like work on it. So it's not that that much of an issue. And what we did here actually, we had this image content where we could load the image from something, I mean from a URL address. We had the agent, which is generic, like you can see, just describe what you see and be helpful for the person that asks. And nothing more complex, like, I don't know, break the image into bits and pieces and try to work. So in that way, it kind of simplifies our usage. After we've seen how agents works generally, you start to think, okay, an agent, one, is wonderful. Can we actually work with a group of more? So here we go back to our wonderful chat agent, and we actually evolve. We don't have only Trump speaking. We have Trump and Kamala. So we wanted to have a debate. For that, obviously, you will need to initialize two agents. Don't forget to run these cells to initialize the options for both Kamala and Trump. After that, the next cell here defines both Harris and Trump agent. Let me remove this. Chat agents, like I told you, have role, goal, task. Role is basically a description of who that agent is. It's important to tell it you are, not be like. Because if you tell it be like, it will start acting as an actor, not being that character. Then goal basically is what it tries to achieve, and task is the way it tries to achieve. And here, let's see what they got. Okay. So basically we have an exchange. Why? Because you initialize the, I mean, it's like a human conversation. Someone says hi, then someone starts talking. Oh, how have you been doing? What have you done? and so forth. So it's a reply, because we have an initial reply using the initial startup seed, let's say, prompt. And basically you refeed it. That's how it works. However, do remember that I told you each agent has its complete memory. So basically each of them, both Trump and Harris agent, will have the whole conversation stored inside it, just that it would have a different order. That's why we can summarize it, and it doesn't matter who does the summarization. For example, summary Trump query summarized the debate, and the debate is made out of Harris memory messages. It could have been as well from Trump. And summary, it's, well, summarization because you don't want to read all the context. Also, since, well, it's like generated, you want to keep it open. But here, for especially our Romanian audience, since we've been just recently, we have more update debates. We had wonderful discussions between Nicu Ciordan and Simeon. So I wanted to see how it performs. And I did the, well, stupid thing, the obvious thing, and just literally copied the code that we had previously with Trump and Kamala and just replaced the name. Also, keep in mind, if characters are not widely known and are generally in a non-English speaking country or language, it would be recommended to actually use that, that language. This is why role, goal, and task are now filled in Romanian. I tried the version with it in English, and it started, oh, you're in the middle of an electoral debate between candidates. So it was a generic stuff which made literally no sense. Also, because, well, we have non-Romanian speakers here also, I made the translator base agent, which basically is fed. It's kind of what you do with ChatGPT. So you take a text and say, translate it to, doesn't matter exactly what language, but yeah, Anton?
Yeah, I want to also say that just clarification. In fact, chat agent and base agent, they're all kind of, chat agent is just a template based on top of a base agent. That means that typically when you instruct agents, what patterns that people discover that works, if you give for each agent, you give like a background, role, and the task to solve. But under the hood, it's just a concatenation of strings, and you can do totally the same as a base agent. You just write it as one long multi-line string that your role is this, your task is this, your background is this. Yeah.
I just want to point out a bit. Remember when I told you that you'll notice a difference later on about basically the models? So because we are using Gemini and not Llama, it takes a bit longer. So as you've seen, these parts where they have to generate stuff, even for me that I have previously run the notebook, still takes time. So in this case, look, it took 1 minute to generate it, which is kind of a long time for 2 replies from each of the candidates. It's true that they talk a lot. We haven't put a limit. However, we look through the debate and it's like a bit weird. For example, let's see. Look, Simeon, apreciez intervenția dumneavoastră. I appreciate your intervention. This is kind of not the type that he would use. I mean, it's not the tone and the likelihood. It doesn't feel like natural. So also, it's general points. I mean, rapid and easy solutions or constructive discussion. We want something more specific. And we know that the model can't be trained on what happened because, well, this happened like not even 1 week ago. So they don't update the model so fast. So what can we do? We want to, I still didn't get for it to use the famous meme, but anyway. What we can do is do basically an online search. Here we're using Perplexity. Remember I told you to input an API Perplexity key is for this part. Here we keep the trend of actually asking in Romanian. Actually, it was a very interesting part because usually I code in English and everything, and I expect returns to be similar both in English and in Romanian. But language actually creates an issue. So if you start a topic in Romanian, you'd better continue it in Romanian, because I had some small parts where I forgot like an introductory hi, and everything went wild. So here in this still executing code box, we do a query to see who actually won. And as you can see, it actually provides the correct answer. So Perplexity did the search. It's basically doing online search without having to write a function to do the search. And because we said it's not entirely, well, in the character, like if you are an actor, you're not in the character. We want to make like a profile for Simeon and profile for Nicușor done. We want like a description, like how would you describe yourself? So let's see. We have, and I inputted some comments here that they should write this description based on this campaign and use it the first person, like like I am, not he is. So each of it begins like, I'm called George Simeon, I ran the presidentials, I was, how was it? Competitive but fair. Okay. I never let a lie pass by without, okay, it's funny in its own way. That's how am I. Direct, untired, somewhere uncomfortable, but always for the Romanians. Yes. So we have here the latest results that are stored basically. And we have a reversal, I mean, both for Simeon and for Nicușor. And we want, and we hope, that these inputs would help us make the characters be more lifelike. Let's see. While it's running, this next box, I'll tell a bit. So, add a chat agent besides role, goal, and task, which I mostly kept it the same with some small tweaks. I edited system prompt. System prompt is made like the general, the upgraded prompt, if you want, the main prompt, how you behave, you know, like you had in previous agent, you're a helpful AI assistant. Because you need to help, you need to answer, you need to be very nice. So in system prompt, we load the profile of both Simeon and Nicușor. Plus, because remember, this is a string. I wanted to add this. I'm presenting my my famous policies like exuberantly, even if they are not to everyone's liking, and I will definitely point them out in every speech, indifferently if they are related or not with the discussions, like what any proper electoral candidate would do. So he would point out like, I will bring greatness to the country, even though you don't know how, in both cases. That's because the agent might skip them forward and keep on its track. Somehow, models are trained to have very polite and nice conversations, kind of unlike humans, and they try to follow a strict flow. Let's see the results. Okay. So if we look, the first thing, Simeon starts to sound more like him, like with a straight answer. Then Nicușor answers like more calmly. So, okay, it actually went better with. I haven't ran it with Gemini previously. I ran it with Llama. So apparently, the more, well, simpler, let's say it's the, I don't know if simpler, yeah, not so detailed is the model, the more easier is to produce like organic answers, not so perfect. And why am I saying that? Because I have ran this topic previously with Llama. And the issue I've encountered is that for every reply, he was like, "Good morning, thanks for your understanding. Yes, I appreciate your point of view." So they had like this kind of connection words, which are polite, I mean, used in polite society, but not when you are arguing with, well, arguing, let's say, debating vigorously with someone. So in this case, I'm actually happy about the reply because, see, we still have it. I understand your passion with which you're talking about, but it's not really that exaggerated. And here, it's because I forgot to change a line, I think. Let me see why. Simeon query. Yeah, I think I forgot to change something because in summary, it still appears Trump thoughts about, so it hasn't overwritten it. Ah, I know why it hasn't overwritten it. Yes. And I mean, you can see the error here in code. It's summary, Simeon query, but I didn't update the debate value. See, this is what happens when you're not paying attention. This debate here, it's a value that is still taken from the Trump discussion. Debugging of code, always fun. Yes, please ask.
So you said you didn't take the debate value, but how we can update this?
Oh, that's actually kind of simple. So the debate value, we can go a bit upwards to see how it was defined. Copy and edit it. Let's see. So see here, debate was defined as string from Harry's memory message. We don't want that. We want, let's go down, back, further down. So here it was. We are going to insert it.
You just add it again.
Yes, and here we are going to change it. It doesn't matter if it's Simeon or let's put Simeon. I actually do not. So we have it like this, memory messages, and we run it again. Yes.
I just wanted to say that you may add a new cell and put the line about debate and printing the debate in order to not reconstruct the whole discussion, because now it will arise the previous.
Yes, you do have a good point, Newton. But
I didn't manage to say it in time. Yes.
It won't be that bad. But we'll see. We'll see now. I mean, it's not that tragic. It's somewhat long, but it's let's just see the output after it finishes. I mean, most took like about 1 minute at most. So you can actually play, well, this thing I'm going to discuss, you can actually play two things. You can copy the cells and do whatever characters you want and try it out. I mean, at a workshop, we had a discussion between, I think, Jesus Christ and Buddha, literally, and they had a discussion between them or something like that, or maybe other characters. I mean, why not? It's still running. Or you can do, we provided here a task. You had the Harris and Trump discussion. You would have to write a chat agent to have like a moderator, so you have a freeway discussion between them. You can practice them actually after, because I mean the notebooks are public. Look, now it finished the run. So summary, it's in Romanian, and actually it refers to the what we had. Yes, Anton?
Well, actually, it matters who summarizes. If you create a cell and ask a translator to summarize debates, and let's see. And also, while we are doing it, I really, the easiest thing, and we did already this workshop in different ways, even like person who has no coding skills can still edit the text in quotes. So what I really recommend is to just change some of the prompts and see how things change. So that's the way, for example, like Dialogue of Jesus and Buddha, it was done by a person who actually, I think it was Sven Bulterich, and he cannot even code. So,
But it was funny. Yeah.
yeah.
Debate. So translate, and we'll put here.
No, not like translate. Let's debate. Let's say summarize the debate, and you just see, you give like the same, but because it's different agent, it has different system prompts. So if it is has to translate everything to English, my estimation that it will make it in English. But let's see. I'm actually curious. Is maybe you should like do this.
So you want like this?
No. I want actually to apply it to debate. So can you use the same prompt that you used for Simeon for summary? Can you copy paste? Yeah, here, summarize the following.
The agent in this summary line. So instead of Simeon,
yeah, but let's separate. We don't want to rerun like
I put a separate cell. Don't worry. So you want like this, and instead of Simeon query, you want translator query?
Yeah.
Okay.
And also, actually, they already know the debates because in memory, translator translated everything. So you don't really have to tell it explicitly. But let's see what it says. You forgot to put it to the end, the summary.
What to put it to
you forgot to output it. Put it
yes.
The cell, Livia.
Summary memory pretty print. No summary, translator memory.
Not it. Just put to the end summary because you didn't put notebook. It shows the last variable, and you have equality in the end.
Anton, I agree with the pretty print idea.
No, but he will show his whole memory. Let's get just the summary. Why do we want pretty print whole of his memory? Just get summary as a here summary. Can you type summary? Okay.
Print. What do you want? Summary.
No, because it prints the variable in the end. It don't really have to explicitly print, and you have a indentation mistake. You had an extra byte space.
Yes, I see that. It has an issue. Now, are you happy? Okay. Debates contrast. Okay. Let's see if it's actually the same See, it's actually not the same translation. I mean, it's not literally, because summary here, if I were to roughly translate it, is candidate proposed stability through like numbers and laws, while Simeon promises Romanianism, sovereignty, exited from the Green Pact and interdiction of selling the land towards foreigners. And well, you can read how it is. So translator actually has, it's like translation and adaptation. It's not just literal, because it says debate contrasts pragmatic governance, facts use, notional lists. Let me see how it went this way. Yeah, land sales. So the main ideas are kept, but the translation is a bit different, as you can see.
That's because we asked it to summarize the debate. If you ask translator to translate the summary from the previous translator or from previous summarizer, it should be literal.
Because it does a separate summarizer in, okay, makes sense. Yeah. So basically, you can play with everything in this notebook. I mean, try, modify, and understand. Now I want to ask actually Anton. Anton, are we going to notebooks 2 and 3, or how do you think?
My suggestion is that maybe let's give, we can probably address a question or two now, while people are playing with prompts and some other people are addressing questions. The only thing that to avoid like asking about things that will be further. So some spoiler alert, next notebook will be dealing with databases, because you have to make agents interact with structural data sources. And so notebook 2 and notebook 3 is about generating code, including bioinformatics code. And we will skip notebook 4, because we had fun with llama instabilities that we didn't have time to fix for notebook 4. And we go to notebook 5, where will be things about retrieval augmented generation, semantic search, embedding, including bioinformatic embedding. And yeah, so about these topics, please don't ask premature questions. And I think like second notebook, I think, Livia, you can cover yourself, and maybe I can deal with third and fifth.
Sure.
That's, I think that matters. So what guys, how was it? What are the questions?
Also watch the chat, Anton, because I'm navigating. Maybe people are typing. Okay.
Yes, don't be shy. Ask questions.
I had a question. Why do all agents like generate the same answers to the same prompt? Like I know, like if you ask AI same prompt, it can give different answers, but I gave like the same prompt as Livia did, and it gave me the exact same answer, like words for words. So does it not like generate different answers?
Well, if you look, so this kind of LLM options, in fact, it's as you can check example in the notebook. It is actually configuration, model name, API URL, and temperature. And we put temperature 0. It means that with 0 temperature, it always selects the most probable tokens. And it means that its variability will be very low. Ideally, it should always be the same, but in practice, it's not. So if you use models that are constantly internally updated, like ChatGPT or Gemini, in different days, you can still see some differences, unfortunately. And typically when you, for this reason, for example, when you test your LLM agents, it's actually the most, like writing an agent is super easy, as you might see today, but the most important is that you have to write a test suite, like questions, answers, and you iterate over prompts. Sometimes you can even make an agent that generates other agents, or that actually iterates over prompts automatically. It's called prompt learning technique. But in all of the cases, you try to ask same question several times because it's not always stable. And another interesting thing that actually many model providers do under the hood is actually when they specifically, it's called consensus, when they specifically run the same model with non-zero temperature, and then they select the best results out of 3 generation. And often it's better than the 0 temperature generation. And there is also a way when you do the same consensus, but not with different temperatures, but with different models. So it's called, so I think it's, how is it called? Actually forgot the exact names, but the idea is that you just try to get the answers from several models, and then you synthesize the best one. Yeah.
No, well, I answered the question about DeepSeek. We haven't tried it in these notebooks because it still has issues with tool callings. We tried it in another project, Just Chat, and it was a bit horrible there because there you heavily rely on tool calling, and it failed because sometimes it returned functions like results from calling. Sometimes it didn't. I mean, it didn't have a very predictable response. So that's why we kind of didn't use it. Both DeepSeek Chinese version and DeepSeek Grok version, because we did try them. And regarding models, yes, you can put. Like I told you here in Just Agents Core, Just Agents LLM options. So in LLM options here, you can do your own model. For example, you want it to be not so exact. You could put the temperature to 0.5 and you'll get slightly different answers. Yes, Anton.
Well, actually, you don't really have to edit LLM options because if you noticed, it's just a Python dictionary. That means that you just have to have a Python dictionary with model, temperature, return. Well, and also we are using under the hood, we are using Light LLM. It's like a library that tries to unify all models under the same API. And they have, in the first notebook, we gave a list of providers. That means that you can actually read documentation and see which models, or like hundreds of models that are supported, and that you can just play around. Another thing is that there are services like OpenRouter, that is like one service that do routing between different providers. So you don't have to bother by having too many keys. You just have one key to rule them on. But it has a bit of overhead because it's just rerouting to like other LLMs. It doesn't serve things directly. Also, you can use models locally. If you want to use models locally, there are solutions like Llama Factory, like VLLM, that allow you to make a OpenAI compatible. So right now, like they call OpenAI, but here it's just an like standard. So everybody has the same API as OpenAI, and they just make OpenAI compatible server with a local model that you run. Typically, you try to like have the best model for the job and the cheapest model out of best, and that's why you can configure different agents with different models. For example, DeepSeek is reasonably good with reasoning, but sucks with tool calling, so you can use it more probably as a like answering. Or if you have domain-specific models, for example, Google recently released medical GMA, and there are also models that are omics-specific, like GeneFormer or like BioFM for genomics, and you can also like have like a very narrow agents that a typical pattern that you will do in large systems is that you don't have just one agent to answer. You have one agent that does routing between different agents, depending on the topic of the question, whether it is general question about a specific topic, or questions that requires tool calling.
Yes, but until then, we'll see actually how the prompts work and influence stuff actually in the next notebook. I gave you a link in the chat, which is the one you're actually seeing here on my screen, and we're going to open notebook number 2. By the way, just a reference, you can have 3 parallel sessions. So after the third notebook, you'll have to start closing tabs because Google Colab will complain that you can't have multiple sessions running sequentially and things like that, just for further reference. So here, we want to inquire SQL databases with agents. So first of all, we must get our first SQLite. And we'll download it. Remember when I told you, obviously, execute. When I told you can have your files online and just download it to run your pipeline, we're kind of doing the same thing. In this cell, we're getting an extract from the OpenGenes database. You're not inquiring it live online, but you're rather downloading a small SQLite of it. Well, smaller, let's say. And then we want to have a function that queries SQLite. As some of you that might have used this format before, you know, it kind of has some syntax, but you might have connections. So we'll run this code to have the function set up. And we're going to try a very simple function. We're going to write the function this time. So let's see what tables are. As you can see, it actually reads the tables that are available. If we have some doubts, we can actually open it. Yeah, I have the SQLite file, but this is how it's structured. You'll actually see it again, I think, in third notebook. So now that we've seen we can download an SQLite and we can query it, we're going to install the basic stuff. So that is just-agents core and just-agents tool. And this is here. By the way, notice that since I didn't have this notebook open, I'm actually having it run at the same time that you guys have. So it's not like instant solving of stuff. So it's installing. Wonderful. And it has run. And here we get to the API. Note. Here we're going to use, apparently I left Grok. Anton, we have Grok and Gemini keys for people. So let's see how it will go. See, when it runs, actually, you've been through this. And I'm going to copy, I have a notepad with Grok keys, because I'm too lazy to actually search for them otherwise. And pasting them. And the Gemini key. And pasting it. Okay. Let's see. This one is like in previous case. And we have here some questions that are regarding those tables. That's why I said here we're going to see some fun with prompts. So let's see. Here our LLM options are defined with Gemini 2 flash thinking, which Anton complained endlessly. It's outdated. Let's just run it with it for a bit and see what happens. Well, it thinks. And we wait because it's slow. And let's see. It has the question. And we see how it asks the question, actually. As you see, it's mutation type knockout. Obviously, nobody is going to put that word in a scientific table. But the model itself is not smart enough to know that it's not supposed to do that. And obviously, it says error occurred during call, no such table, option genes and open genes. Let's see, however, yes, we can edit because I had. Let's see if we change the model. Oh, sorry, caps. Let's take something more intelligent, 2.5 Pro. Would this change the answer? And how it goes. The thing is, with different models, you might get, as I said, different answers. It's not always obligatory. The most safe thing is to prompt bind it, in which case even sillier models can do. Look, what he did here still doesn't get results, but he added organism mouse. So you can see it's smarter. It knows it has to search by mouse, and it's not going to give me the genes of humans or something else. However, it still keeps this thing with knockout, and obviously, and improved, not increase or values. So it's not really good at reasoning. Let's see another question. Here, oh, okay, let's put 2.5 because I don't think it will change the value, but Gemini 2.5 Pro. And let's see what it does. Here, the question seems more like human-like. Genes extend mice lifespan. And see here what happens. Order by lifespan effect, limit 10. Here, the problem is it went, well, crazy. It went formulating a bit hazily. So order by lifespan effect. It's not necessarily a category. So it doesn't know to search in the layers. So we're wondering what to do because we have our questions. We want to have it answered. And let's see how it improved. I have to move this probably. So we have the same model. We have the mice lifespan most of all. And then I said, search all relevant tables in the OpenGenes SQLite and only for mouse. I explicitly mentioned this. And let's see. And keep in mind, this is run with Gemini 2.5 Flash, which also ran previously, but with non-upgraded prompt. Same functions, same files. There's no difference. In these cases, actually, it's more interesting because, users will not. So look, now we have some results, and let's see what it started. Said, select from SQLite where type table. So first it extracted the tables. That's good. Then it searched basically what is contained in stuff. We'll call select where model organism mouse and effect of lifespan extension. Here is where it got a bit of issue because extension does not exist. Select distinct model organism from lifespan change. And then it searches which organism it has. It has yeast, hamster, zebra fish. Okay, that's good for them. And effects on lifespan, no change. So it actually finds what it's supposed to. And look, it actually got replies. So we have a list of genes that having increased value for lifespan in mice, observed in mouse studies. So this was one type of model. And here I said, let's check it with Llama Scout to see if the same query, the same prompt, but with a different model would return similar. Besides the fact that it was faster, I mean, it literally was faster, it seems to have basically the same thing. And let's see the results. So it's also 10. I'm wondering if they're the same values. GHR, prop, GHR. I think they're actually the same. So this brief notebook actually tells us that it's more important than the model to actually prompt engineer it better. Maybe you can have like an enhancer agent in between, because humans in general will post a very simple question like it was here. I want genes that extend my lifespan the most. And LLMs will get their own craziness in understanding. But if you start to develop like increase lifespan the most, then we'll focus. It's kind of like writing emails, when you start to write a sketch of an email, and then you say, rewrite my email to sound more formal and developing and more concise and more precise. Kind of like that you could use. So you don't have the direct question of of the user, so that you'd have an improvement in searches. And for trying out, we had this list of questions. You can actually copy paste and see if it fails or if it fails. For example, why we edited this notebook, as in general why it failed, was that actually the first two questions that now fail, with OpenAI, previously they worked. And when I went to update them and to check that everything works, it didn't. I mean, it was the same question, the same model, because I haven't did it, but now it didn't. So my conclusion is that models themselves can vary. And when the answer is not very stable, it can vary out of your search, which is not what you'd like. So instead of trusting only the model, use the model for its general capabilities, like context size, for example. You've seen how many lines of text they needed to search. I mean, it could be expensive, and maybe you don't need it to be that smart if you prompt engineer it better. So that's the takeaway I would have from this notebook. So kind of this was notebook number 2. Also open to play with and experiment with. I don't know. Well, you can look through the SQLite if you want to ask some other random questions that are not here. I know that this batch of questions was made from it. Yes, Anton, please say.
Yeah, I also want to add that the reason why, for example, here we try to generate SQL and not, for example, Python code, because those of you who often deal with ChatGPT, you know it likes generating code, is that actually because SQL is kind of limited in what you can do, usually models manage to do it better than generating Python code like pandas or polars, data frames with filters and so on. The major issues that you actually saw today and that would hit you many times is that it has to learn the database structure. So sometimes models, like good models or reasoning-based models, they can figure out that they have to query the database to learn its structure. Often you have to help them either by providing a function that renders the structure, or often, you know, even if it knows the structure of the database, it knows like the field name, but it doesn't know the meaning. So usually you provide some explanation of some major fields, so it knows what those fields mean. And another issue that also hits you quite often is that, for example, naming conventions. For example, names and IDs or names of the species, because LLM doesn't know it. It can generate SQL with, for example, animals that are not in the database, or instead of like Homo sapiens with like written in Latin, it just says human. And so there are many like minor details like this. So typically, when you ideally, you should like have an agent that will explore the database and help you to generate the initial prompt that is quite long, that explains how to deal with this database. And another important stuff is that it's better to have few-shot learning in a way that you give examples of queries. So when it doesn't get any examples, it's called zero-shot. If it has several examples, it's called few shots. So if in your system prompt you have few shots examples, you have instructions or tools to get the structure of the database and also to know which values are possible and which are not, then you kind of solve the big part of the task. That is important. Another thing is that, for example, those questions, actually, when Livia developed OpenGene's agents, it was the question that she used to test the agents. So the most important part when you develop anything with agents and with actually LLM in the loop is that you have to write tests. You can actually ask LLM to generate you some tests, because you have to know like how well you are improving, and often you can have regressions because models are not stable, and you have to have a test set and probably continuous integration. And it's actually super easy to do now because there are like IDEs like Cursor or Visual Studio Code with this Copilot features that actually can generate GitHub actions, can generate PyTests and other continuous integrations that used to be like very tedious to write. Nobody liked it. And now actually it generates you pretty quickly, and tests are extremely important. Continuous integration with these tests, like GitHub Actions, for example, may be less important, but still important. And I think maybe we can check if, do we have any questions, or we can go to code generation?
Well, I shared the link, but if you have questions, do not hesitate.
Yeah, we tried some local LLMs. So typically with LLMs, you have a major problem is GPU memory. So to most of, like, for example, I have only 16 gigs of visual RAM, and it's super low. And 16 gigs of visual RAM is actually like pretty good home laptop, but in my case, it actually like enough to maybe run only like quantized 13 billion model. And typically, in terms of models, you use Hugging Face to actually, so there is this Hugging Face leaderboard on LLMs, and you can see you shouldn't like trust it very much, because everybody tries to cheat. So for example, QN, it's a very good cheater. You have constantly like NVIDIA and QN. There are two most cheating companies. So you constantly get like news that, oh, QN managed to get to super high value, or like NVIDIA Nemotron got to super high value, but they actually figure out just how to cheat on it. But still, you can look, like I gave a link to the chat on a chatbot arena, and technically you can check, like for the model, you have to check the size of the model, if whether you can run it on your machine or not.
Maybe you should share the screen and stop, and because you're going to the next notebook.
Yeah. I was just saying that typically models around before 8 billion parameters, they suck at tool calling. Starting from 13, they are okayish, but pretty terrible. And I would say that 30 and more billion parameters are reasonable. And also you have to make sure that to save like space, there are also ways like, it's called quantization. So typically you run quantized models that use some numbers rounding and pruning to get them smaller. But right now, I mean, for major tasks, you typically use APIs rather than like local models, unless you need like to do really long task, like to run something for like days, and you don't want to spend all of your money, and it's not very mission critical. You can maybe deploy a local model and just let it run for a very long time. Okay, so I think what else? Yeah, so we have like, let's do actually the coding agents tutorial. And yeah, so let me make it larger. I think it's large enough. And again, we start from getting the dependencies. And let's copy paste the keys. Actually, I will take the keys from this chat because let me scroll the chat, the keys that I posted. So I would get Gemini key, so that you typically get at Google AI Studio. For Gemini, actually, they give really nice at Grok and Gemini for free accounts. They give really nice limits. That means that for short querying, you can easily use it for free. Okay, they want Grok. Okay, let me see where, because I copy pasted Gemini. Did I? Here is Grok. Okay, let's get. Wow, did it freeze? No. Works. Okay, Grok key set successfully. Wow, it's not asking Gemini, surprisingly. Okay, so here we actually typically the way how you run code is even in our library, you try to make a sandbox. It means that you don't want the code to mess up your environment, because in the code you typically install a lot of libraries, and for this reason you use some sandboxing. So we are using one of sandboxing libraries that we contribute to. And you use either Docker or Podman container. Podman is actually way safer than Docker, and most of the code is run inside of those containers, including installation of dependencies. Here in the notebook, we couldn't properly configure Docker, so we will go ugly way. So we run like actually a function, a code that will run it on the same machine as a Colab. Let's see actually that it works. So typically when you make any tool, you first just check that it works. And then we will just do some simple stuff. So large language models, they are really stupid with numbers. And for this, actually, let's try, if they know how to generate code. And in our case, it's just a tool that you give text with the code. So you see like it has default system prompt, then it understands that it has to generate a Python code, and it gets a response. Then let's go bioinformatics, and here actually so we try it in the beginning, and this agent, it only has a function to run Python code, and it doesn't have BioPython installed. And for this, we have to write a tool that will allow it to execute bash commands. So it will allow it to run some installation. And so technically, it's just basic code that runs and gives error if it crashes. Let's make another agent. So we are using Llama Scout and GrokU, not Grok that Musk uses, but GrokU is companies that developed a chip that can super fast on inference. And that's why everything you run with them is, like you saw already, like 5 or 10 times faster than Gemini or other models. Okay, so let's learn stuff. So it first actually does installation. So you see that output of the installation. Then it so maybe we can just do things properly and get a nice Livia designed visualization. So it did bash command pip install BioPython. It got things installed. Then it actually, just in case, check what is the version and if it works. Then it checked installation, and then it actually ran BioPython and does translation. And after it got results, it actually explains it with human way. With actually code generation, you have to be careful that often you are deceived by what you see from ChatGPT or Gemini with their like chat interfaces, because when you call stuff with API, you often get less detailed answers, because in ChatGPT they store some information about users. They also generate really big system prompt. Here is just system prompt is you are a helpful assistant, and they also have some internal set of agents that do code generation with debugging with. So it's not like here we wrote one agent and that's it. And typically, when you do anything with the coding, you typically need several agents, like one for code generation, another for debugging, and you run it in a loop with like multiple tries to see if we got what we want. If something crashed, it should run and check another like options to debug it. So it's not that as easy as you see with the chat. So this is like for code generation. Another topic is actually what bothers us in bioinformatics is integrating very diverse types of data, because even though ChatGPT or Gemini, they know a lot, typically they don't index the structured information like different databases. And in bioinformatics, we have like millions of genes and gene products of different species, of different like isoforms and so on. And for this reason, we have so many databases that we have to integrate them together somehow. And for this reason, people invented so-called knowledge graphs. And knowledge graphs, the idea is that it's like a huge graph. It can be a graph like, for example, BioCipher projects, they use Neo4j, and they use some schema to just connect different entities with nodes and edges. There are also solutions with SparkQL and RDF, like semantic web, like GraphDB, for example. But the core idea is like on this picture is that you have some, for example, resources like databases on tissues, drugs, genes. Then you have adapters that try to like connect them together and translate them to some compatible format. And then you fill it in a graph, and you also take into account ontologies, because ontologies are typically schema of the data that can be used. And then you have, for example, with case of BioCipher, you have a huge Neo4j graph, and there you generate typically a Cypher queries. So Cypher is a graph querying language. Models know it a bit less than SQL, but it's more expressive, I would say. So in our case, we actually have we deployed one of the knowledge graphs about drugs. So let me actually open the API. So typically when you deal with API, what you open, you see like there, it's not more for humans. So you see just detail not found. If you go as a browser, I will make things like larger. But typically you have Swagger is something that is used for documentation. And actually, I think, why don't I see docs? So typically you add docs. Newton Winter, do you remember, did you put Swagger to BioCipher or not? Because it was your work.
Yes, you just need to access docs on the root.
Not on Biochatter API,
yes,
but
yes, but on the root.
Okay. So it's just not in the common direction. So when typically right now, the trend is that it's a headache to have most of the tools in in code. Typically, you try to make your AI agents interact with different APIs. And APIs are super easy to generate with libraries like Fast API, and they generate this kind of documentation for you. So these are like methods that you can just try out. And here I can even execute and see what is happening. So you have like human documentation like interface. And the most important is that you see this completion. So completion is a universal OpenAI compatible interface that most of the models support, either directly or through light LLM and similar wrapping libraries. And when you call any model like ChatGPT, Gemini, or something, it actually under the hood makes post requests in a streaming mode that it gives like the model, the temperature, some kind of penalties that are model specific. Then what I said about what exactly is this LLM communication is just an array of messages. So what you saw in notebooks in nice colorful things is just this JSON array when you have content and role. And you can also configure if you want to stream it or not, and give some other information. And the thing is, if you you can deploy an agent, for example, as an OpenAI compatible endpoint. It's very easy to do. And we kind of provide such stuff in our library. You can do it like with one command. And here, for example, we give it as an LLM options. So it's not like a model like ChatGPT or something. It's an agent that can have, so here actually it uses ChatGPT 4o mini model, but it can have some functions that it runs. It has tools for querying biochatter and interactions with the database. And here we don't have to provide any local tools because the agent itself has tools on the server. And here we want to ask about, interactions of metformin. Here you see what is happening, that the user asks about metformin. And here it gives results. And it actually also found that SEMA, so it's probably, so it's actually wants to know, first it gets, so cipher query is this, so this is how it looks like, that it matches a pattern in the graph, that it should have a drug called metformin, and it wants ages of drug interaction type. And here it's just a placeholder. So I, it's just where to find the footer. Like, like in SQL, you have variables that in select give results. Here are just, you can call it any way you want. So you get drug name and you get the interactor. And then it got some results, and then it tries to generate queries on those drugs to actually know, for example, for semaglutide, it wants to know a bit more. So it kind of does subsequent queries. And if you, I think here was a limitation on tokens, so it didn't continue. But overall, it can make like a long graph exploration and do serious search. And ideally, in those knowledge graphs, you kind of integrate. You can have knowledge graphs on omics, on drugs, on other things, and ideally, it can search whole biology on what you need. And I'm actually curious, what if I would ask it to answer about rapamycin? It was a query actually about semaglutide. So maybe I can, what drugs interactions of rapamycin? And actually rapamycin has synonyms. I am actually curious, I think it uses pretty weak ChatGPT-4 model, so it's ChatGPT-4 mini model. Maybe it will not figure out to, let's see. Hold on. Result. Why do we? So it was we are using the same agents that it asked about metformin. Now it asked about rapamycin, and then it actually figured out that it's sirolimus. I think Newton Winter, you had like some prompt, system prompt that asked it to also check for synonyms, because it's a typical problem that we have same names for like multiple. Like
yes, the agent under the hood of the server and it handles this task because it's oftentimes a problem if user asks for, commercial name or layman terms. But the database contains the non-patented names of the compounds, so it needs to be converted to the entity name for the query to succeed.
Yeah. So also like a typical headache with LLMs that they don't know that they are not very strict towards biological IDs and sometimes confuse IDs that look like synthetically similar. Maybe like one symbol like IGF-1 or IGF-2. Who knows? Pretty similar. So that's one of the problems. And second problems is that you have to explain it how to deal with complex nomenclature. So they're getting better, but you will constantly have issues that like it gets false positives that just look similar but totally different genes, or that they are not very strict in searching of really specific IDs, or that they forget about different standards. Like, for example, you have ensemble IDs and trace IDs, and they're overall pretty bad with IDs, to be honest. So I think that this is like for the knowledge graph. And Newton, maybe you want like to add something before we go to the fifth notebook about semantic search.
Well, we don't yet have specifically available, like in 1-2 clicks, biochatter tools, but probably we will have such capabilities in future. So you could probably in future use knowledge graphs from notebooks as well.
But you know, guys, also
enough.
it's relatively simple to make knowledge graphs. So also there are wonderful databases, like for example, Synergy, created by Gabi and Robbie and some other participants of these calls. And so if you have like databases that you participated or want to help with, actually it's, I mean, it's relatively simple to make agents that query them, and we can think if we can add MCP servers or if we can add some bots that will answer questions that also involve those databases. So if anybody like wants to try it and make open source, so feel free to contact us. We can help with this. And any other questions before we go?
This is not transparent. The endpoint that we're querying under the hood, it uses just agents, so it's the same library and basically the same code. Just for now, you need a bit of volume of the code to achieve this result. So we wrapped it into an endpoint for simplicity of the demonstration.
It's just several lines of code to serve your agent as a web API. Actually, we have it. We have a whole web agent thing that it's just if you wrote an agent that you saw how to write it, it's just several extra lines of code, and you serve it as an API that you can deal like with this biocycle.
It's just, to my knowledge, it's a limitation. One of the limitations of the notebooks that running a server within a notebook is not a usual thing.
Well, you can do it, but it's a little bit of a headache. Okay, guys, any questions before we go to another part? Mm. Okay, guys, let's go to, so I will give a link. We will now working actually with important part of embeddings. And the reason why they are important is, oh, hold on, let me see. Yes, it's fifth notebook. The reason why it is important is that typically, like you have limit on how much tokens you can fit to LLM. So token is usually a little bit less than a word, and you have like 2 millions for Gemini and 4 millions for Llama, but actually on their peak numbers they get worse. So the more the longer the context is, it's not only that you pay more, but also that you actually get worse answers, even if you don't exceed the limit. And also if you're using free like Gemini or Grok keys, they limit how much tokens you can deal with, and if you exceed it, you have to pay. So here another, so for this you actually need what people say retrieval augmented generation. So technically when you use other tools, like we called functions and give it to the model as tool calls, it's the simplest reg that you do. You just give external sources information, and with databases it's like it queries the database and it feeds the result to the model, so the model like knows more. So any tool calling is actually retrieval augmented generation. In terms of models, we got also not options of simple text-based search like it was in the past, but so-called embedding search. So what actually is it is that because people trained all of those models, so I will just explain for a bit of theory. So most of the models you work with is auto-regressive models. It means that, for example, if it's a text model, it has like a text, and then it, based on previous information, either provided or produced by itself, it generates the next token, and then it just goes token by token, and it uses typically something like a softmax. It's just a probabilistic function that samples out of like completion tokens. So that's how most of auto-regressive models, including transformer, work. There are and models that you typically deal with, like ChatGPT, they are decoder-based models, meaning that they technically complete. You have to provide some initial starting text, or if it's multimodal, can be picture as well, and it kind of starts extending it, and it stops when it generates a stop token. And there are also models that are encoder based. Typically in all models, so as you see in the pictures, that the first step is that because it trained it on a lot of text, it has numeric representation of every token. Like here you see like to, date, and so on. And because it was trained with a lot of completions, it was stimulated to keep similar things closer. And for this type of embeddings, you can get it from decoder models, but usually people also use so-called encoder-based models. That models that don't have to generate anything, they just have to improve the numeric representation of the data to allow similar stuff to be similar, and to allow optimization of it for downstream tasks like clustering. So it's like for clustering, they try to have a loss function that try to cluster things together. For example, if it is sparsity, it tries to focus on the most important connections, and so on and so forth. And this is like if you have like this embedding and you got from text to some numbers and you put it to a multi-dimensional space, typically the most popular embeddings are usually it's actually not ChatGPT, not decoder-based embeddings, but encoder-based embeddings. and it's pretty using because you have to save a lot of text. So what you do in if you want to use this vector parameters, you first encode all the text into numbers, and then you save those numbers in databases that are optimized for storing vectors. And we have the property if it's a good embedding. Here, for example, you see embedding arithmetic. So you see like king, man, woman, gender, and so on. And you can see that closer things are closer together. And you can see that like if we change the gender of a king, we get queen, and so on and so forth. So that's a basic idea. And with this, you can, if you want to find something similar, and if text matching, for example, you have synonyms, like you search for superheroes, but you have to know like that Superman, if it's Superman is in the text, it doesn't sound like superhero. Or if, for example, Spider-Man, it doesn't have any text like super in his name, but it's a superhero. From text search, it's usually not clear. From similarity search, even if you use synonyms or totally different types of writing, it's clear. And for this reason, you can use a similarity search. There are many databases like millisearch, like for example, Chroma, for example, what else? Actually, Quadrant, then Vectara, then like a lot of them, and many traditional databases like even Postgres, they add vector search stuff just to allow this type of similarity thing. So we developed a library that allows dealing with a popular search engine called millisearch. It's like Rust-based alternative for Elastic with a focus that also involves hybrid and vector search. And in this library, we also have some basic functions to deal with embeddings. So typically embeddings, you typically get them from, they are typically small, and most of them are on Hugging Face. And there is a benchmark called MTB. So you can check which embeddings are available. Right now, actually, Gemini embedding seems to be the best one, but many other ones are actually open source and way smaller. So typically, when you need to index a lot of text, you go with a relatively small open source one. We are, for example, usually using Gina embedding v3. It has 500 million parameters, so it's way smaller. And context is around 8,000. That means that typically you have to split the text. So 8,000, so typical scientific paper, I think it's like 20 or 30,000 tokens without supplements. So you have to split it. But the most important part is that, let me see, I opened this thing twice. So here I just add, it's nothing special, it's just a function from the package for visualizing. So just, actually embeddings are nothing than numbers. So you have a sentence transformer class from Hugging Face, and Hugging Face does the download of view of the model. And typically you use a method called encode and gives you text. And typically you get it by name. For popular ones, I provided like an enum that has like exact names, but you can also, if you see it on Hugging Face, you can just give a name. If you write repository a name properly, you can actually get it. I think it takes some time because it needs to download. I hope it will not.
It takes about several minutes. I tried to.
Yeah, it takes some time because you have a lot of GPU-related dependencies and like PyTorch, like transformers that take a lot of time. And typically you get embeddings, and when you want to evaluate how good this or that embeddings is, so first thing is you check, for example, if you need search, you try to get retrieval results. Also, it's domain specific in a way that for biology, you probably need to fine-tune embeddings or take biomedical embeddings to get better. But overall, like, you look at the retrieval. And for retrieval, also, you try to get the model size. So you try to get to limit. So you see like distribution of the model size. So I don't know, I want to get like smaller. Can it filter or not? But typically, yeah, it has some, I think, bugs. But you can actually play a bit with the table. And when you open, for example, you want to see like what this GINA embeddings is, you let me actually run it. Yeah, so typically you just do sentence transformers. You give like the GINA AI, GINA embeddings v3, so this repository name, and Hugging Face does the download for you. And it has like APIs that is like universal, that you can encode text and get numbers. And you can also say which tasks you're using. So here, when you, so the thing is that you encode it with a task called passage, but when you make like a query, the way how it works is that you encode it with a task query, you get a vector, and then it computes, usually it's cosine similarities or similar vector distance scores, like to get like how close the king to the queen, for example. And you get similar things. Let's see if we get actually, yeah, so it's finished. Yeah, it's first time does a lot of downloading. And in models, some depend on others. So GINA depends on Roberta model. So it's fine-tuned Roberta. And here I just gave example of the most popular ones for small embeddings that you can run, for example, on your laptop. And let's do like some stress tests. So one of the way how you define how good it is, you check how well it separates similar and different terms. So we put like this queen, king, dog accelerator test. And also second thing is, for example, how robust it is for type errors, if it can understand random type errors or like I always have issues with the Jean Calment, Jean Calment. Like French is a terrible language in terms of orthography. So yeah, and let's see actually compare, for example, GT large model. I think it's Alibaba-based model with GINA AI. So it downloaded the model, then we visualize it with our words, and we should get like 2 pictures. And you can actually see that queen is closer to king. So you have a cluster like king, queen, princess, and others like apple, oranges. Actually, I don't know, apple and orange are similar, you see it. While cat and dog, well, they should be closer actually than, let me see, cat intersects. Yeah, cats and dogs are closer than cats and oranges. And you can see how it is with the name. So it can understand it's a type error pretty well. But still, there are some issues because things are bad with biological IDs. You can have like a gene name with another number, IGF-1, IGF-2. It will consider be like almost the same. And in biology, you know that often it can be very, like, for example, for cytokines, one is pro-inflammatory and second one is inflammatory. And the difference is only number. And you don't want to confuse something that can inflame you with something calming. And for Gene AI, we do like we also download it, and we will also run visualization. And let's see what it gives us. So here, actually, you see it. It's kind of more stringent. That you see that you have a lot of white things that are so it actually distance things that are not related better, and actually that's why we like it more. But you have to test it on your own domain, because if you work with biology, you select genes and you see how well they differentiate, and maybe models got good for general stuff will suck. And here also you see that it's kind of way more contrastive. And when you train those models, also you use contrastive method of learning when you give things that are different and you ask it to make them more different and other way around. So here are some data. And I will show you also the search. So we have this. I have to probably change the key. But for example, when we, what the heck? .y.environment. Maybe I forgot an import. Okay. Let me see how it is. No, it should be in Python, because maybe I forgot to import from .environment import. Let's see if it works. Actually,
Maybe you
don't know.
need to install the package.
Yeah, but it should be installed. That's why I'm a bit surprised. I have to check it, because maybe there was a crash in dependency load. But okay, we have like stuff already. Like I can give you, to save time, I can give you the results. So you write an agent, you give it two search documents, and typically you try, especially in biology, if you use general embedding, it can confuse like names of IDs and stuff like this, and you try to have a hybrid search, because text-based search are more strict on IDs. That's why it combines according to the ratio it gives, like half results. When you rank, half results will go from semantic search and half with the text-based search that is more strict. And typically here is a search on synergistic lifespan interventions. And the search is done in, so we have this nice server in aging kills. We have this 80,000 of, I think it's on this port, 80,000 of biological papers, and it actually gives a result like it's a bunch of pieces of articles, including like famous Synergy database. And after it, so it got like a lot of results. And typically when you typically get a lot of information, and when you don't want like to pay too much money for the tokens. So here I didn't bother, but I think it went out of context actually. But usually actually it works pretty well. And typically you also use second type of model called re-ranking model, that it's a small model that is optimized to get search results and evaluate semantic similarity. And it does like a filtering, and only the results that are high on the re-ranking model will be fed to the LLM. So, and another thing that the reason why I raised question about embeddings is that it's extremely important in biology, because biological LLMs, they are a bit behind, because it's not as like general topic as general purpose LLM. And the other reason is that we have huge amount of training data on general text and very little because it's expensive to sequence stuff on biology, and extremely like diverse data on biology. It's not like small number of letters, it's like genes, proteins, and so on. And right now in biology, there are models that genomic and transcriptomic models. And the way how typically they do, they train in embedding, and the tokens there. So here is, I actually managed to run locally and send them a pull request, is biofem model. It's a pretty small model, like 500 million, I think. No, this one actually 265 million, but I believe I used a larger version. And the thing is that they just extend the DNA with those extra symbols to mark transcripts and other features, because and they typically focus on, so they train the model with a way that you have to extend the sequence, and you have to predict those features. And if you train first so-called foundational model, so you do like pre-training, you just feed it a lot of annotated data and train it to recognize it and to turn it into numbers. And then you can fine-tune it for different tasks. So you can have loss functions that will, for example, if you have annotations, if it is like damaging mutation, you will like propagate it through loss. So you will like tune it with way less computation for the task. And the thing is that typically the way how you work with it, it's actually really interesting, is that if embedding is good, you can just even take a foundational embedding, because it learned a lot about biology, and you can just run, you can embed, for example, version of a gene that is normal and version that is broken. And then you can train even like a regular linear model. It's called logit probing. And even linear model, if it's good enough, it will be very predictive. Actually, currently linear models trained on biotokens from biofem are more predictive than conventional ways of predicting pathogenic genetic variations now. So we probably will integrate this model sooner or later. And the other example is transcriptomics. And transcriptomics, most of the models are actually trained with single cell data, and there they make a text out of ranked names of the genes. So and then you use the encoding based method that you hide, like you say, this is the gene X, and you have to predict the name of the gene. And that's how they get embedding. And again, it can be fine-tuned for something else. So these are like stuff with the notebooks. And the last, I will end with a small demonstration, because we are getting late, of stuff called MCP clients. So what it is, so now we have integrations of like, for example, in coding editor, you can have this, you can chat with your code and get suggestions, and it saves a lot of time you can generate a lot of code and boring tasks like this. But what can it also do, that here is a fork called Cursor of Visual Studio Code, and it has this MCP server things, and the configuration is the following, that you just say name of a server, type if it is HTTP or local, and like some URL and some basic stuff. And when you ask, for example, I want it to actually, let's actually open my browser and open my presentation. LLM tool, it actually calls it, and I run a tool. And you see, it opens the browser and can call the presentation, and you can make it interacted with your desktop, with your files, so it can read your files. It can open a browser and simulate a user and do some, if it's a multi-context model. And in short, the idea is that the problem with the tools in Python code that you saw is that it's code that you have to run, you have to deploy locally, and have to maintain. While if it can be just an online server or that is provides API, it's way easier than dealing with all those containers, dependencies, and so on. And it can be maintained not on your machine but by the developers. And that's actually, so the core idea is that in the past, so it's just a server that can be called, can provide tools. So your agent just gets a list of the tools from the server, and when it calls those tools, it makes requests. And now we have hundreds of servers, so you can, for example, dealing with WhatsApp, with browsers, with email, so you can add them to your AI-enabled local Claude or your coding editor, and it will be able to interact with many things and do many things for you. And there are also limits, same as with tools. If you add too many tools, it starts to confuse. Around 50 tools, and even Gemini 2.5 makes a lot of mistakes. So ideally, you have to have composers that will first limit the list of tools best for the job before actually giving it for completion. And and typically also, so you have hosts, MCP hosts that deal with the servers, and you also have clients that are applications like code editors or local versions of chats that can deal with it. Yeah, and there was some other stuff, but I want to show you what you can do. So we have this, I gave in the email, I gave a link, there were videos how to install. So in terms of MCP servers, the problem is that unfortunately not much is this. So you have hundreds of servers for different stuff, what you can explore. But if you add bio, almost nothing. And by informaticians, we know how many databases exist. And here is bio, and most of them are this pretty much clones of each other. And we have this bio things MCP that we developed, and we plan to add some for aging databases. And actually, we really need open source contributors, people who want to help us. So how does it work? So BioThings is just API that has a lot of stuff, knows a lot of stuff about genes, about drugs, and so on. It's like my gene info, my chem info, and so on. And when you want to add this server, so here I will show we actually deployed it remotely, but here I'll just show locally. So I run the server locally, and it's just UV run server, and you have this configuration string, and you just copy it to your, I'll make it larger. So I activate, so I select which servers I want to run. And here I see the list of tools. Technically, it's functions, and I can run it so I can see actually for most of those functions, I see just fast API MCP. It's regular way to develop API with additional things that it automatically generates. You have to generate really detailed prompts with examples in your descriptions of methods. And also there are several other nuances, but other than this is just similar fast API based Python server that very easy to learn how to write. And with LLM generation, you can generate many of them. And for example, I want to know like some gene. For example, I can ask, I want to know what you know about IGF-1 gene in human and mouse. And what it does, because it has this biothings API, it runs the query, so you can see like tool call, and the results, it's a lot of IDs and so on. And then it will search in mouse. And then, for example, I want to say, I want to get to make comparison CSV between human and mouse IGF-1 that you found, and save it inside data folder of this project. So you ask this generation, so it will actually create the CSV, and you actually let me try to actually open it. So let's accept an editing, and let's see actually what it generated. Okay, so we have like, but it's not many fields. Can you make fields as raw names and include all the stuff you learned about those genes? Each gene is a column. And you can get so it will do pivoting of the data, and you will like got. But I think originally I didn't ask it to include all of those IDs. So maybe it will not be as detailed, but if I modify the prompt, unfortunately it's Gemini 2.5 Pro, that's why it's kind of slow, and it thinks a lot. So they have this thinking feature. Also, while it's loading, I can just show a few things. So the versions that I'm using is, so we have this repositories biothings API. And the versions that I'm using locally, it's experimental. It has more features than the main that was in the video, but it's still pretty slow. So the plan is to like make a lot of different longevity and bioinformatics open source servers, and that bioinformaticians will just include them in their editors and other MCP clients. And if they want to get some aging related data or make a search, they can do it in just their own coding environments, and can also mix it with code generation. So here actually it generated me a file, and I want to actually see transposed one. And actually transposed one has a lot of IDs and parameters. Then I can play around that. For example, I want to get genomic sequences of those genes and do pairwise alignment, and its result please store in data folder. And here is it's first it initializes. So we have this tool of I believe enters download and trace data. And while it's doing stuff, for those of you who can write code, I can actually show how things look like. That means typically you write this. It's important to know a library called Pydantic because it's the one that is typically used for data structures. And for APIs, you write down so-called models. So it's like names of the classes and fields. And you can actually generate it from LLM when you do JSON calls. So it can do it really fast. Then you make roots. And roots is like name of a method query. Then you use classes that will explain fields. And then you have to write really detailed you can actually, you typically just generate it with LLMs and modify it from just chat inside IDEs, but it's kind of typical instructions how to use it. And then inside it just runs a simple client to the JSON, gets JSON and saves it as corresponding classes. So most of these methods, I did the whole library in one day, actually, in one day, one night. Then I had to do some tests to actually again, generate it with LLMs. But you can really do things really fast if you use LLMs. And it's now downloading the second, it's actually downloading the data. And I assume then it will run a global pairwise alignment to actually see what is the difference between human and mouse genes. And let me actually, yeah, and I can show like for the call. So you see that it's just downloads from NCBI, and here is a downloaded sequence. That's what model got. And let me see. So what it sent for, so it's downloaded again, but pairwise alignment is still running. And the idea is that you can also generate code locally with LLMs using those code editors that you can mix generation with MCP calls and with resolving those IDs. And wow, it actually did something. Look, download. No, it's still downloading. So, okay, let's wait a bit for the download. So maybe there is a question or two that I can address while it's running, actually. Any question, guys?
In the chat, you already have one.
Okay, but I see Livia is answering, so I assume. Well, for alignment, it's typically I just wrote a method. So it's I do right now. I do alignment on the server. So I have this. So I have so the server is I compose it from several mixins like. And I think it's in this downloads mixin. I know it's a bit not right, but run pairwise alignment. Let's see. It uses, I think it uses BioPython, to be honest. So I didn't bother much, but oh shit. I think there is an error. So it kind of saved stuff, but I believe I have to generate code for alignment because I see there was an error on a server. And I have to, I did this feature maybe like yesterday, and this unexpected error occurred during alignment. Number of optimal alignments is larger. Maybe it's, I have to change penalties and match scores. That's why defaults probably sucked. That's my opinion. But anyways, here, like, I think you got the major point. Another thing that actually I can do, so there is like a catalog of those MCP servers, and for each server you just select what you like, and you copy paste like this simple configuration. And for example, if I add a server, for example, I want to do some basic stuff like file management, I can add the server of file system, and I want you to delete duplicates in my downloads folder and sort by and make folders to group downloads. So for again, maybe I should have used float because it will be pretty slow. So I usually have like multiple chats. So I have it like a list of chat downstairs. So for IGF-1, it actually suggested some changes that I don't see, but I think pairwise the alignment crashed, so I have to debug it. But for organizing downloads, I think maybe I should use Claude, because maybe I should use Auto. And okay, it lists the folder. So it gets like names of downloads with a lot of mess. Then it tries to search according to some duplicate patterns. Like sometimes I download stuff multiple times. So it does like a lot of search files calling. And maybe now it will, it creates a folder. So it started creating a folder to, well, now I only gave it permissions for my download, so I'm not afraid that it will mess up everything. So it actually created duplicates, and it's separated by PDFs, archives, and so on. And now it kind of moves files. And I'm actually curious to see what will happen with my downloads. Some of the limitations, because I remember people asked about running bioinformatic pipelines. I think it's, well, like if you have MCP servers that are the pipeline, you have to think about like a long-lasting agent that would actually check stuff in hours. That I think the limitations that things are usually slow, and Cursor is more for coding, so it may not be the best. But if let me look what's happening with my download. So yeah, I see a lot of folders like this. So I think it's getting better, but then maybe I can prompt engineer to actually make, and I can do the same with like messengers, emails, databases, whatever I configure. Just don't have to overload it. And yeah, and I think that's everything that we wanted to share with you guys. We also have like other ideas, but I think we already like for pretty long. And what we really want like to encourage you, those of you who got interested, actually there are some opportunities like bioinformatic hackathons that you can get funding, like BioXYZ 2 months hackathon, where if you make some MCP servers, you can win prizes. So I give a link to biomodels as an example, and I encourage you to maybe contact us and try to make your agents and try to make your MCP servers. And also we have this longevity genie Telegram group, so I encourage those of you who are interested join the group, ask questions, and maybe we can collaborate with something. Last link is a link to download the Telegram group. So thank you very much, guys, and I hope it was long, but you learned some new stuff. And like in the future, if there will be interest, we can cover other topics, because, for example, we have ways to make very easily your own chat assistant, similar to Longevity Genie that you saw, that you can make in a day or two, actually. We also have some research with omics models, but I think if we would push on architecture of omics models, it would take long time. And yeah, whatever you're interested in. Thank you.
Thanks a lot, both Livia and Anton, for this very intense workshop. I enjoyed it to the fullest. I hope everyone did. Also, like these links to the notebooks and the other resources, could we like put it in one email or document so that we have it in one place?
I think that we will do a follow-up email with maybe some questionnaires and useful links after the workshop. In Luma, they have like a button to write a follow-up email. And also we will take some time, so we will upload this video to the YouTube, so those who missed it would be able to check it again. And then, depending on what people want, we can also cover other topics, and happy to look into use cases that you have. And I think that what we are most interested in is that you guys, you should try something, and if needed, reach out for us so we can collaborate with you.
Yes, thank you a lot, Anton and Livia. It was indeed very, very nice. And yeah, looking forward to see you at other workshops or other events. Yeah. To everyone, yeah, I wish you a nice evening, and yeah, stay healthy. People are asking also about emails, Anton and Livia. If you would like to share that with anyone, then maybe they would like to reach out, or maybe it's for you more convenient just
I
in the
think
group.
that for Livia, you should have Livia email. And
I
yeah,
can write it, actually. I mean, I don't have a problem.
yeah, I can write it now, but we will make a follow-up with all contacts, with all Telegrams, LinkedIn's, and so on. So this is mine email. This is Livia's. Also, I shared like Telegram probably can be the best to reach the whole team. And also we have GitHub organization, we have Hugging Space, we have different websites that you can play with.
Thank you. Thanks a lot. Yeah.
Okay, guys, any questions before we finish? Or maybe impressions, wishes, whatever.
Impressions. Anyone? Maybe you could, I mean, I can also help with a feedback form. If you don't have already one, I could also help you with that if you need that anyhow. If not, but yeah.
Yeah,
Thank you very much for very interesting topic and for very interesting seminar. And I'll try to use it in my future investigations for archaeology. I think it will be also very interesting. And maybe I'll write you later for the help. Thank you very much.
Yeah, also it's important to say, like to give feedback when you start working with like libraries, usually, you know, when we develop it for a long time, everything looks easy, and whatever is written stupidly or there are mistakes, often it's not your fault, it's our fault, because we explain stuff not properly. So don't be afraid, and reach out, send pull requests, and so on.
So it's more likely a use case we haven't thought of, because I'm kind of the official bug finder since I'm the latest addition to the team. And then I start, why is this thing working? Because we wrote it for something we wrote like long time ago, but we haven't updated to, and that's why it doesn't work. So usually you will find bugs, but that's not necessarily because you did something wrong. But
so there is a question of Loredana about like volunteers. So yeah, I mean, join the Telegram group, and we would be really happy to guide people. The only thing is that you have to be proactive. That means that you have to check stuff, ask questions, give ideas, because it's really big headache to invent simple tasks and to work with people that if you don't message a person, the person would not contact you, or if the person gets stuck, she will never say that she got stuck. So you would think like a person is doing something, but she's not. So be like really proactive. And I mean, for example, Livia is architect, not software architect, real architect for like buildings. And she managed to learn stuff and contribute. So everybody can learn, but you have to be really active and don't be afraid to ask stupid questions, because often it's we wrote something in a stupid way and not you who is stupid.
Thank you, really appreciating.
I also thank you guys.